everyone, welcome back to another beautiful episode of Just Ask Sage. So, in our last video, we started our series on differentiation, and remember, I promised you shortcuts. So, here are the shortcuts. The formula says that if we have a function y equals ax to power of n, then the differential dy by dx is equal to nax to power of n minus 1. This means that whenever you are differentiating, the differentiation simply means if you have a power of x, you simply bring down that power to the front. That's why this our n came to the front here. So we have na. Then after bringing down the power, you are going to subtract 1 from the power. So instead of n, we now have n minus 1. Let's take some examples to illustrate that formula. So we want to differentiate these functions here using the power rule. Let's start with our function x squared, y equals x squared. So we're going to be finding dy by dx. Now remember from our power rule, I explained that our power rule simply means that you bring down the power, then subtract 1 from the power. Now in this our function here, we have x squared, where our power is 2. So to differentiate the function, we are simply going to be bringing down this power 2. So first of all, bring down the power 2. Then we'll write times x squared. Now, after bringing down the power, remember I said you subtract 1 from the power. So instead of saying just x squared, you'll be subtracting 1 from this square here. So it's simply going to be 2 times x to the power of 1, which is equal to 2x. Now let's solve the second question. Our second function, we are asked to differentiate y equals 2x squared plus 3x plus 7. We are asked to find our dy by dx. Now, we have 3 different functions all in one. So what we're going to do is that we're going to be doing the power rule for each of the functions separately, then add them together. Starting off with 2x squared, remember, bring down the power, then subtract 1 from the power. So we'll bring down this power 2. So it will be 2 times the original 2x squared. But remember, you subtract 1 from the power. Plus, next function is your 3x. 3x also means 3x to the power of 1. So this actually has a power. So the power we're going to be bringing down here is 1. So bringing down the power for here, we have 1 times the original 3x to power of 1. But remember, you subtract 1 from the power. Then for the last function, plus, our last function here is 7. 7 is a constant. Now, the differentiation of a constant is always 0. But let me explain why. 7 is the same thing as 7x to the power of 0. Why x to the power of 0? Because any number or any alphabet or any expression raised to the power of 0 always give back 1. So 7x to the power of 0 is simply same thing as 7 times 1, which is same 7. So we'll be working with this to differentiate. Here, bringing down the power 0, we have 0 times 7x raised to the power of 0, then minus 1 from the power. So now, let's continue. Here we have 2 times 2, that will give us 4. 4x to the power of 2 minus 1. 2 minus 1 is 1. Plus, here we have 1 times 3, same 3. 3x to the power of 1 minus 1, 0. Plus 0 times 7. 0 times 7 is going to be 0. Times the rest of the things there will still be 0. So this will give us 4x to the power of 1 is the same thing as 4x plus 3x to the power of 0. Remember, anything to the power of 0 is 1. So this is the same thing as saying 3 times 1, which will give us back 3. So that means our differential of our function here is simply 4x plus 3. So I hope with all this we've been able to understand how to use the power rule to differentiate functions. Do practice on more questions, and if you have any question, don't be shy. Click on that comment button and comment your question. I will always attend to you. Please subscribe to my channel and stay tuned for more differentiation series. In our next video, we're going to be talking about the product rule.